All right, I thought I would do some of the problems out of 3.9. I thought we'd look first at number 21, and then we would look at 25. And so hopefully maybe you could go back and do 23 since we were doing the odds. If you look at, I'm not going to draw the whole graph or anything. You'll need to look at your book to do that. If you look at this, they have the point 2, 1, and they show the tangent line drawn in blue. And so they ask us to, I missed it, but anyway, it's supposed to hit that point. They want us to estimate f of 1.9, which is the y value when x is 1.9. And then they want to estimate the y value when x is 2.04. And they say we can print an enlarged graph. That's kind of a hint that we're going to be needing to get some stuff off the graph. If you look at the graph of that tangent line, and you were to, it goes to the point 2, 1, that blue line does, and it also hits 1, 0. So if you think about your slope, your change in y is 1 minus 0 is 1. Your change in x is 2 minus 1. 1 minus 0 is 1. Our slope there is 1, and remember our slope is our derivative at 2, okay? So we know that our slope there is 2. That's our first derivative at the point 2. Now, how's that going to help me? Well, if I want to estimate f of 1.9, that would be, if you think about it, it would be f of 2. If I kind of probably need to write this little formula down here. If I want to find the difference in those y values, if I want to find f 1.9, what I can do is I can say that's the same thing. I'll just do this. F of 2 minus 0.01, okay? So that's about the same thing as taking the y value at 2, and then how am I going to estimate the difference in the y that I would get out of this? That's the dy here. I can say, well, it's the y value at f for 2 plus the dy, if you remember, you've got dy equal f prime of x dx from this section. Well, we could put that's f prime of 2. That's the f prime of x because we're talking about the point at 2. So it would be the derivative at 2 times dx. Well, what is the dx here? Well, it's negative 0.01. The difference in the x values between 2 and 1.9 is 0.01, and it's subtracted, so it'd be negative 0.01. Okay, well, we know what f of 2 is. We got this point. F of 2, what's the y value at 2? It's 1. Now, I know what the derivative at 2 is because we were able to count it off. It is 1. The slope is 1. Remember, the slope and the derivative are the same thing. And then my change in my x, remember the formula says I need to change in my x, it was negative 0.01. So if I do that, if I just, simplify that, that's 1 minus 0.01, which is 0.99. Oh, basically that is our dy. That's an estimation of the, that's an estimation of our value there at, that's not 0.99. It's 1 minus, okay, I did this wrong. This is 0. 1.9 would be 2 minus 0.1. I've got my decimal place in the wrong spot up here. Let me correct some things in red. 1.99 would be 2 minus 0.1. So it would still be the derivative of 2, but I need to move my decimal place over here. This should have been negative 0.1. I put an extra 0 in and I just caught it. So that would mean this value is negative 0.1. And so 1 minus 0.1 would actually be 0.9. Okay, so now I've got it. I got my decimal place in the wrong spot. So then when I was subtracting it, I was getting the wrong value. What about if I want to estimate f of 0.04? It's the same sort of thing. F of 0.4, 2.04, that's the same thing as like saying I want f of 2 plus 0.04. Well, that's the same thing as saying that's about, it's f of 2. It's the y value at 2, and then the change in y, I can estimate it with this formula up here at the top. I can say that's the derivative at 2. That's the f prime of x would be the derivative at this point, which is 2, and my change of x here would be 0.04. Well, I know that f of 2 is 1, f prime of 2, again, the derivative at the point 2, we counted it off. That slope of that blue tangent line was 1. And then I've got 0.04. So it's 1 plus 0.04 is 1.04. I can actually estimate that y value by looking at it this way, by saying, okay, it's the y value at 2, but then there's a change in y that comes with this change in x that I have here. So, so anyway, this is how I would do 21. Now, the difference between 21 and 25 is in 21, they gave me the graph and I had to count the slope off. And I was kind of able to do that because they made sure it hit some good points, so it was easy to count off. 25 is going to be similarly done, except it's almost a little easier. We don't have to count the slope off. 25, they give us this graph, and it's the graph of g prime. Basically, they graph the derivative for us, and that's kind of interesting because one of the points they graphed down here was the point 3, negative 1/2. What that means is that x equal 3, the derivative at the point 3, which is the slope at point 3, is this negative 1/2. So I'm going to be using that in a minute, just as I used it in the first problem that we did, 21. Now, they tell me some other things in 25. They tell me they want me to estimate g of 2.93. And they want me to estimate, I'll come down here to do this other one, estimate g of 3.1. And they tell me that g of 3 is 8. I don't have my original graph, but I have a point for my original graph, and it's the one point I need. That's telling me the point is 3, 8. And I need that in order to do what I did in 21, if you think about it. Okay, so if I'm going to estimate g of 2.93, if I think about it, that would be my x value. I've got this 0.38. It would be like saying if I knew my x was 3, my y value that went with it would be g of 3, but I really need to subtract 2.93 is minus 0.07. Okay, now I can estimate that. I've got this far, right? I can estimate that. I can say, well, that's about the y value at 3 plus, it's supposed to be a 3, plus an estimation of that y value that would go with this little change in x. And remember, how I'm estimating that is I'm using that dy is f prime of x dx. Okay, so I'm saying, okay, that's about g of 3. And then I can estimate the change in y that I need here by saying it's the derivative at the point 3 times the change in x. And the change of x is this negative 0.07, because 3 minus 0.07 gives me the 2.93. Okay, now if I estimate this, and again, all of this is just coming from here, g of 3 is 8. They told me that. That was the point they gave me in the instructions. The derivative at 3 is basically this negative 1/2 that they gave me, because they gave me a graph of the derivative, so I can tell exactly what it is at 3. It is negative 1/2. And then this change in x that I had here was negative 0.07. So that's 8. And then if I multiply negative 1/2 times negative 0.07, that would be plus, let's see, 7 divided by 2 would be 3.5. So I think I need to move the decimal place over twice. Yeah, it's 0.035. You can put that in your calculator. And I get the value 8.035. That is my estimated y value for g of 2.93. So since I knew the change in x, I can estimate the change of y that goes with it. Now if I'm doing 3.1, it's sort of the same thing. I want the y value. If I think of 3.1, I could write it as g of 3 plus 0.1. Well, I know what g of 3 is, and what I need to do is estimate the change in y that would go with this change in x, 0.1. I can estimate the change in y. Remember, that's the little formula they gave me. I'm circling it up here in red with f prime of x dx. So I can say, okay, that's add in f prime at 3. It has to be at the same point. And my change in x here, sorry, I meant to put a parentheses and I put a triangle. My change in x is 0.1. Let me put it down below here. It would be multiplied, okay? So what is g of 3? They told me that. It's that 8 there. What is the derivative at 3? Oh, they told me that because they gave me the graph and they told me the point 3, negative 1/2. So it's negative 1/2. And my change of x here is 0.1. So that would be 8, and then 0.5 times 0.1 would be 0.05, and this is a negative 0.05. And if you could put that in your calculator, that's basically about 7.95. So this is what we're doing here. We're basically saying that if I know my value, my y value at a certain point, and I know the change in x that goes with it, I can say, well, the change in x that I know, if I just could find the change in y that goes with it, I can estimate the change in y as f prime x dx, or g prime x dx, I guess. That's what I've been doing here. And then just filling in these values. And this g prime of x, we either counted it off the graph because we counted the slope, or we were given it in the problem because they gave us the graph of the derivative.